Okay, here we are. Positive and negative angles. So, if an angle rotates in a counterclockwise direction from the positive axis, then we consider that to be positive. So if we start here and we're rotating this way, this is a positive angle. Woo! All right. If we start here on the x-axis and we rotate that way, that is called a negative angle. There we go. Perfect. I got an extra little thing there for no reason. Notice that angles can be bigger than 360 degrees. So like if I'm starting here, I can describe my motion and rotate all the way around 360 degrees, and I could keep going. So this exact picture, that would be 360 degrees plus an extra 90. This would be 450 degrees. So you can rotate more than once around. That might be important to note. Yep, so when an angle rotates clockwise, we have a negative angle. Said it again. And again, it can be more than negative 360. So here would be negative 360 degrees. And again, I can rotate more. And let's do that many rotations. So that would be 360 degrees, an extra 180. So let's do some math. That would be negative 540 degrees on that one right there. Perfect. I'm a little off today. Okay, angles that end up in the same position are called coterminal angles. Now, coterminal angles is one of the easiest things to understand, but ends up being one of the most important concepts that's sort of embedded everywhere throughout this unit. So pay extra attention here for sure. So, if they end up in the same position, they're called coterminal, and there are an infinite number of positive and negative coterminal angles for any angle. So, how do you find a coterminal angle? Well, you merely add 360 degrees to a given angle. So say I have an angle of 40 degrees, and if I was to do a sketch, this angle might look something like this. 40 degrees, right? There's 90. So there's my sketch. If I want to find some coterminal angles that are positive, so coterminal positive ones, just add 360 degrees. So if I go 40 plus 360 degrees, I will get 400 degrees. So that's a coterminal angle. And if you think about it, really what I'm doing is if I start here on 40 degrees and I rotate a full 360, do you see how I've landed in the same exact spot? So I got the same terminal arm, except I've now gone 400 degrees all the way around. So if I take 400 degrees and I add 360 to it again, I'm going to get another coterminal angle of 760. So 40, 400, and 760, they all land in the same place on the unit circle. That's what makes it coterminal. If I want to find negative coterminal angles, then I simply rotate in the opposite direction. So I would subtract 360 degrees. Okay, so I can take my 40 degrees, I can subtract 360, and I would get negative 320 degrees. Again, I can take the negative 320. If you're
interested, there's a whole bunch of free candy up front in the school here. You got kids, or you just want some candy for yourself, there's a whole bunch here. Come and get some.
There is free candy, and I have to record this. Oh my goodness, it's all going to be gone when I get there. Okay, so negative 320, negative 680 are coterminal angles with 40, but they're negative. Right on. Right, a negative angle that is coterminal to 100. Well, we can just do a bunch of examples. So take 100, subtract 360, and you're going to find that negative 260 degrees is the same thing. Write a positive coterminal angle to negative 19 degrees. So there's negative 19, add 360, and ooh, what do I get? 341. There, didn't want to do that one in my head. What is the reference angle in quadrant 1, or what reference angle in quadrant 1 is in the same position as 500 degrees? Okay, so remember, reference angles are the angles that are in quadrant 1, so they have to be between 0 and 90. Now, if I have 500 degrees, that means that I must have started here, I went around at least once, then I went around some more, and I landed, somewhere over here, who knows. Anyway, to figure out the reference angle, just subtract 360 until you get an angle that is hopefully in quadrant 1. Let's see. If I subtract 360 once, I get 140 degrees. Now let's think about this for a second. So if I go and sketch 140 degrees, that's 0, that's 90, that's 180. So I know that 140 is somewhere in quadrant 2, so I rotate that far around, 140 degrees. Now, the reference angle always lies between the x-axis and the terminal arm. So right here, this reference angle would be 40 degrees because it has to add up to 180. So that means that in quadrant 1, 40 degrees is a reference angle for 500. Woo! Perfect. Remember, we generally write it with a theta and then an r for theta reference. So this is old stuff from sort of grade 11. Write a statement for all the angles that are coterminal to 30 degrees. So here on the exam sometimes they ask you to write a statement that gives you all the coterminal angles. So what you do is you write 30 degrees plus or minus 360 times k, where k is an element of the integers. And that would be a statement that would give you all of the coterminal angles to 30 degrees. Wonderful. Remember this because it does kind of come up on the exam. All right, we got sort of a try it yourself thing here. Let's take a look at what we got. Determine the measures of all the angles in standard position between negative 1,000 and 1,000 degrees that are coterminal with an angle of 150. Okay, well, we can do this. Sketch all the angles. I don't think we're going to sketch all of them, but we can sketch a couple of them for sure. So if you're going to be coterminal with 150, then we're going to want to add 360 and see what we get. So we add that, we get 510. So we're still less than 1,000, right? So remember, we're going to be between negative 1,000 and 1,000. So I'm just looking at this and I'm like, oh, I can go a bit further. So take that, add 360 to it, and then I get 870 degrees. And I'm like, okay, if I add 360 again, I'm going to go out of bounds. So now take 150 and go towards negative 1,000. So subtract 360, and I think you'll get negative, negative, is it 210? Yeah, negative 210. Okay, now take negative 210, subtract 360, you get negative 570. We still haven't hit negative 1,000, so take that. I got one too many zeros there. So negative 570, subtract 360, and you get negative 930. All right, so what are all the angles that are coterminal? Well, you can state them all, starting with the smallest one. Down here, so you go negative 330 degrees, negative 570, negative 210 degrees. I guess we can state 150, that was the original angle that was given. 510 degrees and 870 degrees. There. Now, as far as sketching them all, let's just sketch a couple. So I'll sketch 150 degrees. So how would you sketch it? Well, again, you need to kind of remember that these quadrants go up by 90 degrees every time. So 0, 90, 180, 270, and then 0 is also 360 once you do a full rotation. So to sketch 150, I'm obviously in quadrant 2 somewhere, so you would just draw your terminal arm like that. Then you have to draw the rotation. So this is the only indication that I know of which direction I'm traveling, and then you would just write 150 degrees, and that's how you would do that one. Let's do maybe one of the negative ones. So let's sketch negative 210. So that would be a good one. I'm just going to point out, because we're going to be doing a lot of this anyways, it's always handy to be able to find the reference angle. So again, it's always between the x-axis and the terminal arm. So from 150 to get to 180, I would have to add 30. So that's my reference angle there. Okay, so I said I would sketch negative 210 to show you guys a negative angle. Okay, so remember, negative angles still start over here, but you're rotating clockwise. So this time it's 0, negative 90, negative 180, negative 270, and then negative 360. So I start here. Now if I'm going to sketch negative 210, I'm obviously somewhere here in quadrant 2. So I'm just going to go ahead and do my rotation first and sketch my terminal arm. And then I can say, okay, that is negative 210 degrees, and that would be enough. I just wanted to point out that you can still find your reference angle here as being 30 degrees. Okay? Right? Because from 180 to 210 has to give is 30. So that reference angle is still the same. You're going to notice that these two sketches are the same. Right? Terminal arm in the same place, still have a 30-degree reference angle. The only difference is here we traveled 150 degrees counterclockwise. Here we have to travel 210 counterclockwise. So that is something to know. Right, part B. That's a really quick one because it's just asking for all the coterminal angles of 150 in standard position, like the formula. So you would say, well, I take 150 and I either add or subtract 360 degrees times k, and k is an integer. Wonderbar. There's that one. We're making some good time. Okay, trig ratios on the unit circle. So this is straight up from grade 11 pre-calc. So a little bit of review for you. So we got a thing called a terminal point, and it's an xy point, and it lies r units out from the origin. So what you get is you get your origin, you plot your point P, x, y, and then this terminal arm is the radius of a circle. So if I was to turn that all the way around, I get a nice little circle. So it all follows that I can drop a straight line down here, I can get a 90-degree angle there, and from here to here would be my y value, whatever I have here, and from here to here would be my x value. And then we can sort of restate the Pythagorean theorem. So we have a right angle triangle. Instead of saying a squared plus b squared is c squared, we now write it with x, y, and r. So you remember this formula here from grade 11 pre-calc. So this was also the formula that describes the equation of a circle. We don't do it anymore in grade 12 pre-calc, but we did when I was in school, because I'm 1,000 years old. All right, this is the equation of a circle, blah, blah, blah. Perfect. So there it is. Pythagorean theorem in the unit circle is the equation of a circle. A couple of things to remember. So we then go ahead and we actually restate all our trig ratios that you learned in grade 10. We restate them using x, y, and r. So just remember, sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. All right? So that's what you would have learned in grade 10. The good old SOHCAHTOA, right? In grade 11, we started using this terminology, right? So if we go back to our drawing, if we just sketch a little theta here, which would be the reference angle, sine theta is opposite over hypotenuse, or y over r. Cos theta is going to be adjacent over hypotenuse, or x over r. So there you have it. Sketch it in here. So this is now x over r, and then tan theta is a y over x. Perfect. This is on your formula sheet, by the way. This is probably the easiest way to remember trig once you know about the unit circle. So we run into some examples, and these ones are from grade 11. I give you a point, and I say it's the terminal point of angle theta in standard position. What are the values of sine, cosine, and tangent? This is a good question to review. So draw a little sketch would be my recommendation, and then plot this point wherever it happens to be. So the point 1, 2, 3, and 1, 2, 3, 4. There it is. Doesn't have to be perfect, but there you have it. You can drop that down, draw your 90-degree angle. If you want, you can label that unnecessary though. So this is 3 units, that's 4 units, and that's r. If you're going to find sine, cos, and tan, you're going to need to find r. Well, it's really easy to find r because you got the Pythagorean theorem. So you can copy that down. You can plug in your numbers. So you got 3 squared plus 4 squared. And I don't know if you guys remember, but the 3, 4, 5 triangle, if you do the work, you're going to end up getting that r is the square root of 25, or that r is 5 units. So now you can go ahead and you can find sine, cos, and tan. So we know that sine theta is a y over r. So that means that we got 4 over 5. There's that. We know that cos theta is x over r. So cos theta is going to be 3 over 5. And then last but not least, over here, we got tan theta. That's y over x, which is 4 over 3. Wonderbar. Beautiful. That's a nice little question. This is another question of the same type, just a different point. So I'll quickly sketch it, and then I might just give you the answers. So it doesn't matter where, like just go plot that point wherever it ends up being. So x is positive, y is negative. I'm in this quadrant over here. So I'm just going to sort of try to make it a little bit bigger than maybe I normally would draw it. So this is the point 1, comma, negative 3. So my x value is 1, my y value is negative 3. I don't know r, and there's theta. Okay? So obviously go find r. So you're popping it into this equation. You'll never get negative numbers in here, right? Because you should always use brackets. I don't bother if my numbers are positive, but in this case I got the -3. So you're going to get 9 plus 1. So you're going to get that r is the square root of 10. Now here's the good news. You don't need to rationalize. They don't care about it, thank goodness. So sine theta, which is y over r, you can just write as -3 over the square root of 10. Okay? Cos theta is x over r, so it's 1 over square root 10. And then tan theta is y over x. So -3 over 1, you could just reduce it down to -3. So there you have it. That's all they're asking us for, so we've done that one. A little bit more information for you. So each of the 3 trig ratios has a reciprocal. Now this is new. This is new to us. Now the reciprocal is when you go 1 over y. When you do 1 over y, the reciprocals are important enough that we give them their own names. So the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is called cotangent. So if you go and you take your formulas, if you take cos theta and you do the reciprocal, so if you switch r and x, you get secant theta, so that is the official lettering of it. Secant theta is r over x. Take your sine theta, it's cosecant, so CSC theta, it's r over y, and then cotangent theta is x over y. Now, every once in a while in the exam, you get little questions like this. So they say, hey, is the value of sine theta 0.5? What's the value of cosecant theta? Well, remember, cosecant theta is 1 over sine theta, right? It's 1 over y. So if I go 1 over 0.5, I'm going to get 2. So I could say cosecant theta equals 2 in this case. If I have cotangent theta equals -3, well, remember, cotangent theta is 1 over tan theta. Now they're asking me what is tan theta. So if you resolve this for tan theta, you're going to get tan theta equals 1 over cotangent theta. Well, cotangent was -3, so if I just pop that in, there you have it. Tan theta would have been -1/3. Beautiful. Let's get to the meat and potato type questions. So here we are, meat and potato kind of questions. This is the same question we just did, where they give us a terminal point. The thing is that this time they're asking us for all 6 trigonometric ratios. So that means sine, cos, tan, and then cosecant, cotangent, and secant. So the inverse ones, sorry, the reciprocal ones as well. They already drew the picture for us. So we have our theta. There we go. There's our reference angle. We can plug in what we know. X is -2, y is 5. Let's go find r. So just plug in the numbers, -2 squared plus 5 squared. So that's, what is it, we get 25 plus 4, we get 29. So r is the square root of 29. Again, don't reduce it, just leave it like that. They don't expect you to do any of that work. Yeah, here we go. Let's kind of do it down here. So what I'm going to do is I'm going to say sine theta. Now remember, that is y over r. So the y value is 5. The r value is square root 29. Sine, the reciprocal is going to be cosecant. And you just do the reciprocal. So you just go square root 29 over 5. There's those ones. So I sort of recommend that you do each trig ratio and its reciprocal together. So cosecant theta is -2 over square root 29. Secant theta is the reciprocal of it. So do square root 29 over -2. And then we have tan theta, which is just y over r, or sorry, y over x. So it's -5 over 2. And then cotangent theta is -2 over 5. There you have it. Sometimes they ask a question like that on the exam. If you're having some trouble remembering like the lettering, like sine and cosecant, this is how I used to remember. Cos theta and secant theta are reciprocals of each other. So you'll notice, I'll just use a different color here. You'll notice that they have those letters in common. So I used to remember, oh, secant theta, oh yeah, it's got the C and the S in common with cos theta, it goes with that one. Tangent and cotangent are a bit easier to remember because they both have the word tangent in them. So that's easy to remember. And then it's like, okay, the other one is the one that goes with sine theta. That used to help me out. Perfect. Okay, second question type. If you're given one ratio, find the other ratios and the angles. So this is a very, this is more likely the question that comes up on the exam. So what they like to do is they give you one of the ratios, they tell you some sort of information that helps you locate what quadrant you're in, and then they ask you for other information that you can derive from drawing that triangle. Okay, so the thing to remember here is if cos theta is equal to negative 12 over 13, remember the definition of cos theta. Cos theta is x over r. So that means that x is negative 12 and r is 13. So now when you sketch your picture, they tell you that you're in quadrant 2. So what you can do is just draw like a terminal arm in quadrant 2. And you can go like that. Drop that down. Now x is negative 12. R is 13, and you don't know what the y value is, but you can find it using Pythagoras. Perfect. Keep in mind that your R value will never be negative, right? Because it comes from a formula where everything's squared. So this will never be negative. You need to watch out when you calculate y that you get the right sign. Okay, because the formula is always going to spit out a positive value. So in quadrant 2, my y values are positive, so I won't need to change anything. Just watch out and remember. All right, so here's our formula. We can resolve it for y. So y squared is r squared minus x squared, and we can go ahead and pop everything in. So what was r in this case? It was 13. So we're going to go 13 squared, subtract. What do we got? Was it negative 12? It disappeared on me. Yes. Yes. Perfect. So we get 169 minus 144, which is going to leave me with 25, I believe. Yeah. So it's going to leave me with the square root of 25, so I'm going to get 5. So there we go. Now we know that's 5. So they're asking for the other 5 trig ratios and also the value of theta. So we can go ahead and we can do that, no problemo. Possible values of theta. So from 0 to 360, perfect. Let's find the trig ratios first. We already have cos theta, but we can go find sine theta, right? So it's y over r. And tan theta, that's x. That's x over y, right? Opposite. No, sorry. It is, I'm a liar. It is, eraser. I am a little out of practice, I'm not going to lie. It's been like 10 days or so since I've had to make a lesson, so here we go. Yeah, so it is 5 over negative 12. That's a 5. There. Go ahead, find the reciprocals. So cosecant theta, so if you do the reciprocal, that's 13 over 5. Cotangent theta, again, do the reciprocal, so negative 12 over 5. And then you can write the reciprocal of cos theta, which is secant theta. And that's going to be 13 over negative 12. So there you have it. There's all that information. Now, the other things they're asking for are the possible values for theta. So generally what that is they're looking for the reference angle in here. So they're looking for, well, what's the reference angle in there? So take any one of your ratios and plug it into your calculator to find the reference angle. I'm going to go ahead and just use the one that was given, I guess. So cos theta. So when you go find that reference angle, you're going to go inverse cos, and you're going to plug in 12 over 13. Make sure you plug in the positive version of it, otherwise you're just going to get some negatives on your calculator that might confuse you. So if you go pop that in on your calculator, make sure you're in degrees. I don't know if I actually have that on my page here, so I'm going to type it in. 12 over 13, and I get 22.6. There. So any of your trig ratios that you plug in would give you that. So this is 22.6. Sometimes they want to know how far you have to rotate from here to here. So in that case, I would go 180, because that's 180 degrees here. Subtract 22.6, and oh, lordy, what would I get? 157.3 would be how far I have to rotate from there to there. Okay. Whew, that's a long one. What else have we got? These are some try it yourselves, but I think we should do at least A. just because A is kind of a tricky one because they're giving us cosecant theta. And they want us to find the exact values of the other trig ratios from 0 to 180 degrees. So this is basically the way that they're giving us what quadrant we're going to be in. So we're going to land somewhere between 0 and 180, probably, when we figure this out. So how do we do this question? Well, remember, they're giving us cosecant theta equaling 3. Well, cosecant, to find sine, I just got to go 1 over cosecant to find sine. So now I know that my sine theta is 1/3. Now if you go plug it in on your calculator, so go find your reference angle. So type in sine -1, I'm 1/3. And I got, well, what did I get? I didn't write it down. So let me plug in inverse sine of 1/3. 19.5, so 19.47, we'll round for convenience, we'll just round down. So we get 19 degrees. So what this means for us is that we are in quadrant 1. So we can sketch our triangle. This is 19 degrees. There's my 90-degree angle. Remember, we have sine theta equals 1/3. Sine theta is y over r, so my r value is 3, my y value is 1. I can go find my x value. So remember, the x squared is going to be r squared minus y squared. So when I do the whole thing, I'm going to get 9 minus 1, so I get the square root of 8 for x. Now, always consider what quadrant you're in. I'm in quadrant 1, so it's going to be positive square root 8, and there's no need to reduce it. They're asking for all the trig ratios, which is sort of annoying. Let's just do cos theta, which is x over r, right? So you get square root 8 over 3, and tan theta, which is, opposite over adjacent. So there we go. So y over x, 1 over square root 8. There. Are there any other ways this could happen? Okay, so could I have a reference angle of 19 degrees and have that same ratio? Well, the answer is yes. Now notice how they said from 0 to 180. So from 0 to 180 would also include quadrant 2 potentially if I could replicate that triangle. And you can indeed replicate that triangle. So you can have a reference angle of 19 degrees, and that would give you the same ratio, 1/3 for sine. And the only difference here is you're going to get negative square root 8 for the x because you're in quadrant 2, and then that would change sort of all of your trig ratios. So now cos theta is negative 8 over square root 3. Tan theta is 1 over square root, or negative square root 8. And then sine theta is still 1 over 3. There you have it. Now they're also in part B, so that's part A. In part B, they're saying to the nearest degree, determine possible values of theta in the domain from negative 360 to 60 for this. So if cosecant theta is 3, what are some of the degrees that can get us to these triangles? So what we're asking for is basically, what are all the ways we can have a reference angle of 19 degrees from negative 360 to 60? So when they give us a question like this, break it down from 0 to 360, okay? So how can we have sine theta being positive, and this is a grade 11 question, by the way, so if you're sitting there being like, huh? The only thing that's different is, in grade 11, we would never have given you this information. In grade 11, we would have just said, hey, sine theta is positive 1/3, find all the angles, determine all the possible values for theta from negative 360 to 60. So when we did these in grade 11, we broke them down. Do the positive side first, okay? And you have a theta, r value of 19 degrees, and sine must be positive. Remember, your sine is like your y values, okay? So where are my y values positive? In quadrant 1 and in quadrant 2. So one possibility is that my theta can equal 19 degrees. The other possibility is I rotate that far and get my 19 degree reference angle. Well, this is 180. So if I go 180 minus 19, I'm going to get 161 degrees. So there it is on the positive side. And remember, what does this mean for us? It means that if you go and you type in sine theta, you will get 1/3. So if you type in sine of 19 degrees, you should get 1/3. Now remember, we rounded, so we're not going to get exactly 1/3, but if you type in sine 19, I get 0.325, okay, instead of 0.333, okay? So that means if I type in sine 161, I would also get 1/3. So that's a crash course in that. How do you do the negative ones? So to do the negative ones, that's a little bit trickier. They do like bringing that up in grade 12. Well, the negative ones, you still are looking for places where your sine values are positive. So that would be here and here. When you're doing negative angles, you are rotating this way. So when you sketch this one and you write 19 degrees here, remember, you start here and you have to rotate all that way to get to that terminal arm. Okay, and this is negative 90. This is negative 180. So how much more do you have to go to get to this terminal arm? Well, you're going a negative 180 degrees, and you go 19 degrees more in a negative direction. So that's going to be 180 negative, subtract my reference angle, and I'm going to get negative 191 degrees. Over here, you have 19 degree reference angle. You have to rotate all the way around like that. This is negative 360. The easiest way to find it would be to start at negative 360 and then add 19 degrees. So here you have it. Negative 360 plus 19, and you get negative, oh boy, can I do this? 341 degrees. Done. So there are 4 angles that give you that sine theta ratio of 1/3. That is a very hard question, and we're going to see it again and again and again throughout the unit, so don't feel too bad. You can always pause and go back. Find all the values of theta if tan theta equals 1 from negative 360 to 360. Well, we can remember that if we go type in tan of 1, you're going to get 45 degrees. So where are all the places where you get a tan value of 1? If you remember, so if we just look from 0 to 360, if you remember the places where tan is positive, it's positive over here in quadrant 1, and over here in quadrant 3, right, where both x and y are negative, right? That all makes sense because tan theta is y over x. So if the ratio of y over x is positive, if this is negative and that's negative, overall your tan theta value is positive. So one answer is 45 degrees. The other answer, so you're starting here, you got to rotate all the way that way. That's 180. So you went 180 degrees plus 45 more, so that's 225 degrees. I'm going to show you a neat little trick now to find some negative angles. So instead of drawing the picture, if you can find your positive ones, there's an easy way to go from 0 to negative 360. Just use coterminal angles, okay? So 45 degrees, what's a negative coterminal angle to 45? Well, just subtract 360 and you'll find it right away. So that's negative 315 degrees. And indeed, so if I rotate all the way that way, I get back to here, and that would be 315 degrees. Do the same thing with 225. So just find the coterminal angle to it. So subtract 360, and you're going to get 135 degrees negative. So negative 135 degrees. So there's your other answer. Beautiful. All right. Now this is a try it yourself. Maybe I'll give you some answers for it. How about that? If you're having troubles with this one, just email me or let me know. So I'll get you started. So here they're giving you secant theta. Well, I can't work with that, but I know that cos theta is the reciprocal of this. So if I do the reciprocal of 4, I get 1/4. So that's your first step. Then go find your reference angle. So type in inverse cos of 1/4, and you're going to get a reference angle of 76 degrees. And that's either rounding up or down. Then it's asking you, be careful because they're asking from 0 to 180. So that's going to restrict your answers. So what do I got here? Let's see. You're going to get an R value. If you sketch it, oh boy, I'm just going to end up doing the whole thing. So X is 1, R is 4. When you go and find Y, you're going to get something seems, let's see. So y is r squared minus x squared. So you get 16 minus 1. Okay, so you get the square root of 15 for y. So it asks you for the trig ratios. So, you know, you'll get sine theta is square root 15 over 4. And then you can find the other ones. Good enough. So for part B, notice how it's asking for all from negative 360 to 360. Find your positive ones first, and then use coterminal angles to find the negative ones. So I'm just going to give them to you. So you need to find a place where the cos theta values are positive. That's your x values, right? Cos theta is equal to x over r. On the unit circle, you learned that r is 1, so cos theta is the x value. So where is it positive? Here and here. So you're going to get 76 degrees, and you're going to get 284 degrees in quadrant 4. Now, to find the negative coterminal angles, just subtract 360 from both. So you are going to get negative 76 for one of them, and you're going to get negative 284 for the other. Wonderbar. We are done. Boom. All right. I do believe we're getting close to the end here. This is a very long lesson. I really do apologize. This is the question where they give you an angle and then they ask you to determine the trig ratios. So they say determine the exact values of the 6 trigonometric ratios for 510 degrees. I wrote a little hint here. You need to find the coterminal angle for 510 degrees first. Okay. So if you don't ever have the angle that's in quadrant 1, then you're not going to be able to do this question very easily, okay? So to find that angle, I'm just going to take my 510, subtract 360, and that gives me 150 degrees. Now if I subtract 360 again, because I'm not in quadrant 1 yet, I'm going to get a negative angle. So I need to think about what an angle of 150 degrees means. So that would be over here in quadrant 2, I rotate 150 degrees. That would be my reference angle. Now I know that's 180, so my reference angle must be 30 degrees. Now once you know that, you'll be able to go do a lot of work with that. So we're finding all of the trig ratios. Okay, so it's sort of unclear if we have our calculator or not on this question. The point is remember how you guys memorize these values in grade 11? So a value of 30 degrees, I don't know if you guys remember. I'm gonna have to go back and review. I'll post that unit circle up online. But the point here for an angle of 30 degrees is going to be square root 3 over 2.5, and that's the xy points. Remember, so long side is always that one. The short side is always a half. So now that they're asking me for the exact values, I can actually go find them. So, because I know my reference angle, right? So sine of 30 degrees, which is the same as 510, that's a half. And then cos of 30 degrees, well, that is square root 3 over 2. The tan value is going to be y over x. So if you go 1/2 divided by square root 3 over 2, you're going to end up getting 1 over square root 3. That's another handy one to memorize. Now, those are the primary trig ratios. To find the inverse ones, you just have to flip them, right? Just do the reciprocal. So if you do cosecant theta, that's the one that belongs to sine theta, so you get 2 over 1. If you do secant 30, that's going to be this one, square root 3 over 2. And then if you do cotangent, sorry for my screwed up C, that's going to be square root 3. Perfect. Okay, that was a pretty tricky one. I might choose to skip B here. It's just the same one, but we give you a negative angle. I will mention that for this one, it's not an exact value. So when you try to find a positive coterminal angle for it, you're not gonna get one. Like it's a weird value. Remember, you guys memorize these ones here. So you memorize 30, 45, 60, 90. So if it's not some multiple of this, it means that you need to use your calculator. So to do these ones, you would have to go to your calculator and type in sine negative 416, and you'll get the corresponding ratio as a decimal. So, oops, you get negative 0.829 for that one. If you were to go do cos of negative 416, you get 0.559, and I'll give you tangent. I've never seen a question like this on the exam. The trig unit represents a third of your exam. So we've got 2 chapters on this. It's a third of your exam. They tend to stick to the questions that require like the memorization stuff. There are calculator questions, but they're a little bit different. So, whew, we are almost there. Just remember, if we make the radius of the circle become 1, then that is called the unit circle. So all of a sudden our equation x squared plus y squared equals r squared becomes x squared plus y squared equals 1. So if they ever ask you to find out, hey, is this point on the unit circle? It should satisfy this equation. So if you plug in the x and the y and you square them, you should get the value 1. Remember, I was just talking about this before. Sine theta is y over r. Well, when r is 1, you just get y over 1. So sine theta is now y. Cos theta is x over r. R is 1, so you get cos theta equals x. And this is going to remain the same as y over x. Okay, this is only on the unit circle that this is the case. Everything we do is on the unit circle. Perfect. All right, this is just a really handy diagram. Notice that the size of the circle is not important when you're doing trig ratios. You get similar triangles, so this is actually really neat. Right here you have a radius of 1, and here's the corresponding theta value. If you scale it up, you can get r values that are not 1, but are still on the unit circle because they're actually similar triangles. If you don't quite get that, that's okay. Just know that if your r value isn't 1, that doesn't mean that it might not be a similar triangle, and that's usually the type of questions that we do. Okay, that was really, really long. I'm really sorry. That's brutal. Watch my 10-minute maths and give me suggestions, because I like to take these things and turn them into 10-minute long lessons so they're a lot easier to digest. We'll see you next time. Bye-bye.